Hi, geometry. I know I just posted a lesson today about 12.4. 12.5 is actually the lesson you're supposed to be working on today, so I'm going to go over this lesson as well. And I'll also put up 12.6 so that this week you'll have everything you need. All right. Um, we're talking about trigonometric identities. This is actually, if you're a puzzle, if you're a person that likes puzzles and games, this actually is kind of a fun activity. Most of you are going, no, it's not. Well, we have what are called identities, meaning this is the same as that. And you're going to be trying to prove, these proofs are a lot easier than the other proofs. What you're going to try to do is make one side look exactly the same as the other side. Okay? So here are some of these identities. This is known as the Pythagorean identity. If you take the sine squared of any angle and add it to the cosine squared of that same angle, you will always get 1. And you can test it out yourself. In fact, you're going to have to, I think the beginning, one of the things in the first homework things is write the sine squared of this, the cosine squared of that, and see what it comes out to. These are called reciprocal identities. You flip them over. The secant is the reciprocal of the cosine. So instead of being the adjacent over the hypotenuse, it's the hypotenuse over the adjacent. The cosecant is the flip of the sine. So it is the hypotenuse over the opposite. The cotangent is the flip of the tangent, so it's the adjacent over the opposite. But these are how you're going to be using them. Remember, the secant is 1 over the cosine, cosecant is 1 over the sine, tangent is sine over cosine, and cotangent is cosine over sine. Now, you can keep this, write it down. You might want to copy it right off the board or copy right out of your book so you can keep it next to you while you're doing these. Let me show you how this is done. They want you to prove that sine x plus secant x equals tan x. The first step to doing these is change them to sines and cosines. So if you have secant and you have tan, use your identities and change them into cosines and sines. So you know the sine of x is already okay, but the secant I can change into 1 over the cosine. The tangent is the sine over the cosine, according to that. So when I multiply these two together, I get the sine over the cosine equals the sine over the cosine, and then just put a little check mark. You're done. You've made one side equal the other side. Now, another thing I want to tell you is there's always more than one way to do these. That was the easiest way to do this. You're going to come into more complicated ones later on when you're doing trigonometry. As long as you end up with one side equaling the other side, you're done. It might take you 100 steps, might take somebody else 10 steps, but as long as you get it done, it's done. Let's take a look at this. Whenever you see something that needs to be multiplied, multiply it, okay? Because this is 1 plus cosine, it has none of those match up. So FOIL it. 1 times 1 is 1. Cosine times 1 is cosine. Cosine times cosine, are they, I'm sorry, did I, no, this was supposed to be minus, I'm sorry. So 1 times minus cosine is minus cosine, and plus and minus is minus cosine squared of x equals sine squared of x. So FOIL that correctly. Now look at this. Cosine minus cosine cancels. So I end up with 1 minus cosine squared of x equals sine squared of x. Well, take a look at this. I can move this over to this side and make it 1 equals sine squared x plus cosine squared of x. Sine squared plus cosine equals 1. So 1 equals 1. See what I said? It's just substituting and changing it so that each side equals each other. Let's look over here. Cotangent squared of x plus 1 equals cosecant squared. So we want to change everything into sines and cosines first. So cotangent squared is the same as cosine squared over sine squared. So make sure if this is squared, you square it all. Plus 1 equals 1 over the sine squared. Let's multiply both sides of these equations. Let's multiply every term by sine squared. Or alternately, you can just get a common denominator here. Let's do that because I want to make sure you see why you would do this. If I was to make this denominator sine squared, I would have to multiply top and bottom by sine squared to get the common denominator. So I have sine squared. So let's put it all over one thing. I have cosine squared of x plus sine squared of x over sine squared. See, I just added these two fractions that have the common denominators, equals 1 over sine squared of x. Well, what's cosine squared plus sine squared? Well, the commutative property of addition says that's the same as sine squared plus cosine squared, so that's just going to be 1. So 1 over the sine squared equals 1 over the sine squared, and you're done. Okay? These are not super difficult. Keep those next to you. Try to have a logical thinking mind, but most of these are not really difficult.